Hello everybody, my name is Conrad Coleman, Managing Director of FAR UVC Africa, and I'll be your host for the duration of this seminar. Firstly, I'd like to extend a big welcome to our 196 delegates that registered for the event from 36 countries. To start the event, I'd just like to do a bit of housekeeping. You'll notice on the side of your screen, you'll see a few icons being questions and polls. You can post your questions here and vote on polls that we will be putting up a little bit later in the seminar. At the end of the seminar, we will answer any questions that haven't been answered and announce the outcome of the polls. FAR UVC 222 nanometer disinfection technology has been gaining worldwide recognition for its ability to destroy viruses and bacteria effectively and safely in the air and surfaces in real time in occupied spaces. There's been much talk and skepticism regarding the safety and efficacy of this technology. And with this in mind, the FAR UVC community decided to produce a light bulb moment. To answer these questions and hopefully put an end to the skepticism, paving the way for the rollout of this amazing technology. Our first speaker, Dr. Viktor Tarashenko's interview has been pre-recorded due to the time difference in the time zones. We've also subtitled the recording for ease of reference. So without further delay, ladies and gentlemen, Dr. Viktor Tarashenko. First speaker is Dr. Viktor Tarashenko. Viktor F. Tarashenko received a PhD degree from the Institute of High Current Electronics, SB Ros-Tomsk, Russia in 1976, and the DSc degree from National Research Tomsk State University, Tomsk in 1988. He is currently a chief researcher of the Optical Radiation Laboratory, Institute of High Current Electronics, and a professor with National Research Tomsk State University and Tomsk Polytechnic University, where he joined in 1994. He has also co-authored more than 900 publications, 70 inventions, 23 reviews, 11 monographs, and 3 textbooks for his students. His research interests are in physics of gas discharges and generation of runaway electrons, spontaneous UV and UVU sources, Xe lamps, and their application. Good day, Dr. Tarashenko. Thank you for taking the time to talk to us today.
Good.
Dr. Tarashenko, you're widely considered to be the inventor of FAR UVC. Could you give us a bit of insight into the history of your contribution to the development of FAR UVC 222 nanometer?
Before we investigated excimer including 222 nanometer. In beginning 19 was interest to Xe lamps with wavelength, and we developed first our Xe lamp. Publication was in 1992 or 93. During next week, I show collect reference for this work. In parallel, this development in this field, Dr. Kohryshats begin. Maybe you know about his work.
Yes, we do. Excellent. So you say that this was originally invented in 1992, correct?
Yes.
Okay.
First publication. Just a moment, I check.
No problem.
Yes. First publication was 1992 about krypton chloride Xe lamp.
Fantastic. So it was invented in 1992.
1992, first publication.
Fantastic. Thank you for that information. And Dr. Tarashenko, can you elaborate on the research that has been done since the 1990s on FAR UVC? Obviously, FAR UVC is becoming better and better known in the industry for its sanitation, etc. But could you elaborate just a little bit more on the research that has been done since its development in 1992?
раньше начал, да? I know publication for ultraviolet C in Japan. Professor Abara publicated paper with pumping microwave pumping. It was 1988. But in this work use krypton fluoride XLM 249 nanometers, not 222 nanometers. First publication when I know.
Excellent, excellent. And tell me, Dr. Tarashenko, is there any other new developments in this field of far UVC? I see there is some people trying to develop LEDs or new technology with regard to sanitation lamps and lamps that can sanitize air and surfaces. Are there any new developments in this product?
As I know, semiconductor light sources, these devices use same length of vacuum wire, but now availability of these light sources lifetime is small, and power density is smaller if compare electrical discharge XLM. First of all, krypton chloride XLM.
So what you're saying there is that the semiconductor lamps, they put out less power than krypton chloride lamps, correct?
Yes.
Okay, fantastic.
Maybe in future will be success in this field, but now highest average power has krypton chloride XLM. Second place, it's maybe krypton bromide XLM, 206 nanometers, and iodide lamp, 206 nanometers. Our laboratory development all types with XLMs and lamps.
Okay, excellent, fantastic for that information. Well, Dr. Tarasenko, just from myself and everybody that's put this the seminar together, we want to thank you for your time and sharing your knowledge with us today. And also thank you for taking the time to develop and invent this amazing product. As you know, today with the viruses and the outbreak of COVID-19 and everybody being aware of viruses, this is a very relevant product for us to be using now. One question I would like to ask you just to end the interview is, do you, in your belief, are far UVC lamps firstly safe to use around people when they're filtered? And secondly, are they able to kill viruses and bacteria?
Of course, these sources are very good for killing bacteria and virus. In our laboratory, there is a group, Dr. Sosnina, who investigated influence different wavelength of bacteria and virus. We have some publication in our laboratory in this direction. This was checked, but this activity in our country is very positive because you need a lot of money shortly and special permission, special rooms for this investigation.
Yes, as we have the same here. Well, Dr. Tarasenko, once again, thank you for sharing your knowledge on this amazing technology with our delegates, and we look forward to engaging with you in the future. So thank you very much for your time, and we will chat again soon. There you go. It's fantastic to hear from the inventor of far UVC and to realize that this technology has been around since 1992. And certainly without Dr. Viktor Tarashenko's amazing mind and will to develop this product, we wouldn't have this product available today. Our next speaker is Dr. David Brenner, the Director of Radiological Research, Accelerator Facility at the Center for Radiological Research at Columbia University. He is also the Principal Investigator at the Center for High Throughput Minimally Invasive Radiation Biodosimetry at Columbia University. So welcome to Dr. David Brenner.
Good to be here.
Excellent. Good day, Dr. Brenner, and thank you for taking the time to chat to us today. Dr. Brenner, as a general consumer, as you know, when people talk about UVC, the first thing we think of is, oh, you know, it's dangerous, and we've all been told we can't be underneath it, and it'll give you cancer on your skin, and it'll damage your eyes, etc., etc. Could you give our delegates some insight into the development of far UVC and what makes it so different to the UVC that we all know?
Sure. So UVC in general covers a range from less than 200 nanometers up to 280 nanometers. And conventional germicidal UVC, that I think what you were talking about, it generally comes at 254 nanometers from a mercury lamp. And there is no doubt that mercury lamp 254 nanometer light can penetrate into the skin and to the eyes. Far UVC is a lower wavelength range, somewhere 200 to 230 nanometers. And that has much less ability to penetrate the skin and the eyes. It gets very strongly absorbed by proteins, and of course all biological materials contain proteins. So it really can't penetrate significantly through the dead layer of the surface of the skin, the stratum corneum, or the tear layer at the surface of our eyes. So that's why it's different from conventional germicidal UVC at 254 nanometers.
That's quite amazing, because whenever you see a picture of the conventional UVC, the 254 nanometer UVC, one thing you do notice in those pictures that there are no humans around when those lights are on, correct?
That's correct. And you can't, in practice, directly expose people to significant doses of 254 nanometers.
Excellent. So what we're saying here is that, if I understand you correctly, is that the biggest downfall of 254 nanometer UVC, that people can't be in the area, far UVC has now overcome that hurdle.
Yes, that's exactly right. We hope that's true.
Excellent. Dr. Brenner, can you tell us a little bit more about, obviously, we know that you've been testing this product for quite a long time. Can you give us a little bit more, information about how you've tested this product, how long it's been tested for, a little bit more info on that?
Well, we first pointed out this potential for a differential between damage to microbes like bacteria and viruses and damage to humans, the skin and the eyes, about 8 years ago. And certainly we've been working on it ever since. But I will say that in the past 4 or 5 years, lots of other groups worldwide have been doing research both into safety and into the efficacy part of the story.
Fantastic.
Clearly, you have to understand both. You have to understand, is it really safe? And you have to understand, does it really work?
Absolutely. Dr. Brenner, the other question I want to ask you is, I've noticed that many of the manufacturers or distributors of far UVC products, they're putting filters on them. Could you explain a little bit more about why filters are being used on far UVC products?
Yeah, and we certainly think that if we're going to use this in occupied public settings, you do need to filter the light. So the background here is that the krypton chloride eczema lamps that Dr. Tarashenko invented, and what is pretty well universally used at the moment, although it's the most likely wavelength for emission is 222 nanometers, there is a background spectrum of light going up to 250, 260 and higher. And those, even though they're fairly small components to the overall spectrum, they can be significant in terms of damage to the skin. So we really need to filter out almost all the wavelengths above about 235 nanometers. So that's the importance of the filter, to get rid of the small amount of the higher wavelength UVC light.
Excellent, thank you so much. Dr. Brenner, what some of the questions that we are asked is, how come far UVC can actually kill a virus or a bacteria, but it doesn't penetrate through your skin? Could you explain that a little bit more to our delegates?
Well, it's simply that viruses and bacteria are very small indeed. They're typically less than a micron in size. So the far UVC light can penetrate into a virus or into a bacterium. But for example, the stratum corneum on the surface of skin is quite a few microns in thickness on average. So it can't penetrate, or it has very limited ability to penetrate through the stratum corneum. So it's simply a matter of size. The microbes are very small indeed.
Excellent. Thank you for the answer. And tell me something, Dr. David Brenner, does far UVC kill all viruses, all bacteria, etc.? Or does it only relate to certain viruses, certain bacteria? Or is it just, or can it kill everything, basically?
Well, in principle, it can kill everything. And the reason I say that is because the type of damage that UVC in general produces is random damage. It randomly damages locations within the genome and the protein. So it's not like a drug, which is targeting some specific location within the bacteria or the virus. I mean, in our own work, we started looking at MRSA, drug-resistant bacteria. It was very effective there. Then we went to influenza viruses, and then we went to coronaviruses. And it's been effective in all those scenarios, and pretty well equally effective. So our expectation is that it's pretty well equally effective against all coronaviruses and their variants, and it will be equally effective against future pandemic-related viruses that we might have in the future.
Dr. Brenner, you talking about, you mentioned AMRs, superbugs and antimicrobial resistant bugs, etc. You had on your TED talk, you gave an indication of how many people you thought would be affected by superbugs and AMRs by the year 2050, and your guesstimate was about 10 million people a year, and that was in 2017, I think it was. If we look at the trajectory now, I think the deaths this year are about 1,700,000. So this is clearly, obviously, the next big issue that we're going to be, that hopefully we don't, but it certainly looks like it's the next issue that we're going to be dealing with worldwide from a disease point of view. So my question to you really is, now that we're all getting back to the new normal, let's call it, and restrictions are being lifted around the world in the UK and all over, do you still see a market for a product such as UVC and the UVC devices that people are promoting and pushing into the public and public spaces? Do you still see a market for this product?
Well, let's talk about viruses and bacteria separately. So starting with viruses, and yes, we hope we're moving towards the end game of the COVID, although we don't know that for sure. But speaking for myself, I don't want to live in a world where another pandemic can occur at any point. So the idea behind installing far UVC lights is that, I mean, had they been present at the start of COVID, the SARS-CoV-2 virus would certainly have been there, but it wouldn't have had the global impact that it did have. And so when the next SARS-CoV-2 virus appears, we would like to have far UVC lights in place in all sorts of different locations where people mix, and so that the impact of the next big virus will be correspondingly a lot smaller. And then turning to bacteria, as you say, every prediction is that the issue of drug-resistant bacteria is going to become more and more relevant to us over the next few decades. And again, one of the great things about UVC light is it doesn't care whether the bacteria is drug-resistant or drug-sensitive, because it kills by an entirely different mechanism. So it's perfectly good at killing drug-resistant bacteria. So being that that's a big issue that we're all going to face, that's the other area where far UVC, I think, is going to be able to have an impact.
Absolutely. So really it's about prevention is better than cure, or prevention is better than panic. Let's put it that way.
For sure.
So the sooner we start rolling out this technology, the safer we all are going to be around the world. Fantastic. Well, Dr. Brenner, thank you very much for your time. From all the delegates and from all of us that have put this seminar together, we really appreciate your time. Thank you so much. We look forward to engaging with you at the end of the talk with regard to some of the questions that might be answered that we might need you to answer. So thank you very much, and we'll chat to you in a couple of minutes.
You're welcome.
Thank you. Excellent. Great to hear such valuable insight from a respected and renowned far UVC expert. And Dr. Brenner has certainly been instrumental in promoting the product and getting far UVC out there to the masses and trying to get everybody to understand this technology and to accept this technology so we can start rolling it out. All right. At this point, we'd like to ask 2 poll questions. You'll see on the right-hand side of your screen, they'll be put up there for you to vote on. The first one being, do you believe this product, in other words, far UVC, is safe to use in occupied spaces? That's the first poll question. And the second poll question, do you believe this product is effective in destroying all viruses and bacteria? These polls will be put up. Please vote on them, and we will give you the outcome of these polls at the end of the seminar. All right, on to our next speaker. Our next speaker is Dr. Ernest Blatchley III, otherwise known as Chip. Dr. Blatchley is a professor in environmental engineering at Purdue University in West Lafayette, Indiana. He is currently the Vice President of the International Ultraviolet Association. Professor Blatchley has led research related to UV-based applications for more than 30 years. He and his group began working with far UVC radiation more than 15 years ago. Recent work has focused on the use of far UVC radiation for disinfection of air and surfaces. He is also currently serving as chair of a task force that is being convened by the International Ultraviolet Association, or IUVA. Good day, Chip, and thank you for taking your time to chat to us today. We really appreciate it.
My pleasure.
Excellent. Chip, could you give our delegates a bit more background regarding the task force that is being convened by the IUVA on far UVC and its outcome?
Sure. Outcomes are incomplete, but we're working on it. The task force was convened to basically bring together a comprehensive summary of what we know and what we don't know about far UVC for disinfection of air and surfaces. There have been a couple products of this task force. The first was a white paper that was posted by the IUVA to its website in May of 2021. And I believe the URL for that could be posted so that if people are interested, they could download that document. It's about 30 pages long. Again, it describes, at the time that we assembled that document, what we knew, what we didn't know, and perhaps some suggestions for research to address those what we don't know questions. More recently, we've submitted another paper for publication in a referee journal, and we're waiting on responses from the reviewers. So the general idea here was that we wanted to summarize specifically how effective far UVC is for inactivation of various bacteria and viruses, pathogens in general. What are the effects of far UVC radiation on human tissues, specifically the skin and eyes, and then also the potential for ozone formation.
Excellent. One of the questions, or one of the challenges that we found certainly in the industry is regarding regulation. Obviously, with far UVC coming to the market so quickly, because of the pandemic and hitting us so quickly, regulation became quite an issue. Has there been a change in regulation recently with regard to the amount of UVC that one can be exposed to?
Yes, there has. So the sort of the organization that we sort of refer to for this is the American Conference of Governmental Industrial Hygienists, or ACGIH. And they, 30 years ago, established allowable exposures as guidelines, not regulations, based on wavelength. And their original guidance on this was, I'll just give you some numbers that I have written down here, 22.9 millijoules per square centimeter at 220 nanometers for a day. That's a dose of radiation that they 30 years ago identified as being acceptable at that wavelength, 222, which, as Dr. Brenner mentioned, is sort of a characteristic wavelength for these krypton chloride excimers. More recently, they updated those based on what we have learned recently about the actual behavior of this radiation in terms of its ability to penetrate human tissues and cause damage to them. And those current limits are 161 millijoules per square centimeter for the eye. That's basically a 7-fold increase. And 479 millijoules per square centimeter for the skin. That's a 21-fold increase. So what that suggests is that if your eyes are protected, ACGIH is suggesting that you could safely be exposed to 21 times as much as they previously identified as the guidance value.
Fantastic. And on your skin, how much did they put that up to? 479 millijoules from 23, correct?
Correct. Yeah. So again, it's a 21-fold increase.
Yeah. Wow, that's a big increase. Also fantastic news because it obviously assists in showing people that far UVC is indeed safe and that you can be under the light, etc., within reason, obviously.
Yes.
Chip, I wonder if you could explain to our delegates also, there are many products on the market at the moment, UVGI, so upper air UVC products, there's UVC air sanitation products, there's UVC robots, etc., etc. If you could just give a quick sort of summary on those products, and then how does far UVC fit in with these products, and where are the big differences?
Sure. So just to reiterate, as was mentioned earlier, so the term far UVC, first of all, is sort of an informal definition and basically represents radiation between 200 and 230 nanometers, whereas the broader term UVC, at least in practical terms, represents radiation between 200 and 280. So far UVC basically represents that subset of shorter wavelengths, more energetic, less ability to penetrate, but very effective for disinfection. So in terms of the other terms that you used, for example, UVGI, that refers to ultraviolet germicidal irradiation. That's a common technology that's used for disinfection of air and surfaces. And there's lots of different ways that can be implemented. The most common implementation involves low pressure mercury lamps, which emit basically at 254 nanometers. And as Dr. Brenner mentioned, there are some hazards that are associated with that are not present at the same level with far UVC. Again, in terms of practical applications, what that implies is that whereas conventional UVC, low pressure mercury lamps, or perhaps common LEDs would be used in an upper room configuration where you irradiate the top part of a room that's not occupied by people and keep the exposure in the lower part of the room to an acceptable value. In those systems, you really rely on circulation of air between the irradiated upper part of the room and the lower part of the room that's occupied. And you rely on that circulation basically being met by the HVAC system in the room. With far UVC, there's the potential to implement this in a whole room technology where an occupied space would actually be irradiated. It still needs to be done under circumstances where the exposed dose to skin and eyes of humans is below the limits that have been suggested by ACGIH. But there is more flexibility in the sense that there's the constraints of irradiation of the lower occupied portion of the room are less severe than they were before. And then, in terms of robots and other things like that, that really depends how is the technology implemented. In a robot, what's going to happen is there's going to be one or more sources that are basically on a moving platform that's going to move around a room. Again, we need to pay attention to how much radiation is delivered for purposes of inactivation of pathogens, and also control that radiation to below an acceptable limit for anybody that might be exposed. The bottom line is that there's a lot of different configurations for these things, but they all have more or less the same constraints to work with.
Okay. The only difference is obviously that for UVC, as long as you're keeping within the ACGIH regulation, you're not constrained to obviously passing the air through the top of a room, etc. It's just easier to implement as long as you're obviously staying within the ACGIH regulation, correct?
Correct, yes.
Okay, excellent, fantastic. There's been a lot of change, a lot of talk about air change per hour, ACH. I see lots of regulation is coming in, and basically for the delegates, ACH is air change per hour. So there's been regulation here in South Africa. I think it's 9 air changes per hour in a room, in a closed room, let's put it that way. This can't really be achieved by HVAC systems as such, because that's really recirculating the air unless it's got UVC in the HVAC system, but it has to be obviously achieved by either opening windows, opening doors, and making sure that there's a draft through the area, which makes it quite difficult if you're in a cold area or in a very warm area. There's a lot of people who are, well, there are certain technologies, freestanding, let's say fan-driven devices that have got UVC in them, etc. How does FAR UVC compare to these kind of freestanding devices, and what are the downfalls or the issues with these devices, if there are any?
Yeah, so let me come back first to this term ACH. That's a common metric that's used traditionally in the heating, ventilation, and air conditioning business, or HVAC business, to describe how that system is performing. And in basic terms, it describes how much fresh air are you bringing into the room. The larger the number of ACH, the more fresh air you're bringing in. So that is certainly a common strategy that can be used to control the concentration of airborne pathogens. The downside of that is that you have to pay to either heat, cool, or condition, in terms of humidity or whatever, that air. So it's a somewhat energy intensive approach. We can compare directly the performance of a UV system, or for that matter, a filter, to an HVAC system in terms of, we oftentimes use the term equivalent air exchange. And so it is possible to directly relate these things. In terms of UV, the two parameters that really govern the number of equivalent air exchanges that we get with a UV system are how much UV power is implemented within the system and how sensitive is the airborne pathogen. And as has been mentioned previously, it turns out that the airborne pathogens that we really care about, things like SARS-CoV-2, influenza, I mean, you choose the airborne pathogen, pretty much all of them are very sensitive to UVC radiation and to far UVC radiation. So it turns out that we can, with relatively modest amounts of UV radiation, we can achieve really remarkably high equivalent air exchange numbers. And it's less expensive in terms of energy and other costs to do so than to rely on physical air exchange. Does that answer your question? Is that really where you were going?
Absolutely.
Great.
Because obviously running your HVAC systems at full power, or turning all your fans on, etc., draw a lot of power. And these days, everything is green, trying to use less power, etc. So it seems that UVC certainly fulfills not only a sanitation purpose, but also, from an energy purpose and a green point of view as well. Chip, in your opinion, are there any disadvantages to using UVC? Obviously, as long as it's within the regulation, are there any disadvantages of this product?
Not in terms of the technology. I would say that the disadvantages really are a lack of familiarity and lack of standardization. The lack of familiarity, I think, will be addressed by events like this. The lack of standardization is being worked on. There are various organizations right now that are developing standards for implementation of these systems.
Excellent. We look forward to seeing that, so we can start rolling this product out. One other question I want to ask you is, the UVC lamps, I think it was either yourself or Dr. Brenner mentioned they had mercury in them. Far UVC lamps, as far as I know, they don't have any mercury in them. Is that correct?
That is correct, yes.
Excellent. So that's also great. Ozone. Ozone has also been a question that's been brought up. Do these lamps generate ozone? Is it something that we should be concerned with?
Great question. So the answer is yes, they do generate ozone, but the next question is then, how much do they generate? And so in a general, I'll give you sort of an abridged version of this, and I'm happy to try to answer more detailed questions if they come up. You can start forming ozone at wavelengths less than about 240 nanometers. So far UVC by definition fits into that range, and it does have the ability to generate ozone. But in terms of the how much question, it really generates at a pretty low rate at 222, such that we can keep the concentration of ozone in a room where far UVC is being used below acceptable exposure limits really pretty easily, just using conventional HVAC, as we talked about previously. So if we have air movement in a room and there is some fresh air being provided, then it's really pretty easy to control the ozone concentration around these devices such that the exposure is acceptable.
Okay, excellent. So ozone, we don't need to worry about too much with far UVC. That's fantastic. Well, Chip, thank you very much for your valuable contribution to the seminar. We'll engage with you in a couple of minutes when we get to the Q&A session. And from all of us, thank you very much for your time. It really is appreciated. Thank you.
My pleasure.
Great. So we're going to go to post another 2 polls. The first poll that we're going to post is, do you believe far UVC is more effective than fan-driven air sanitation products? It can be a yes, a maybe, or a no. You'll see it in the poll. And secondly, do you believe far UVC is more effective in sanitizing air and surfaces compared to upper air UVC, UVC robots, etc.? You can also answer that yes, maybe, or no. Please remember to vote on the polls, and we will give you the outcome of the polls at the end of our seminar. How do we know that the product is working? So, which is always quite a difficult question to answer, because we can't put a light into a room and, for instance, let's say the light takes paint off the walls, come back the next day and the paint's off the walls, and we can say to the client, look, it does work. Also the fact that it's not visible light. So we always get the question of, so how do I know that my device is working without having to buy a special device to measure the output of the lamp? Just talking about the output of the lamp, just as a side note, you have heard Chip mention millijoules and nanometers. So millijoules really from a far UVC device is the energy that comes out of the device that kills COVID and viruses, bacteria, etc. And it takes a certain amount of millijoules to kill different kinds of viruses and bacteria. And then nanometers is just the way that far UVC is measured, kind of like centimeters, millimeters, feet. It's measured in nanometers, just to put that into context. So with regard to the question of how do I know that my device is working, our next speaker is Dane Ronholm, and he is the sales director of Intelligo Technologies in Stockholm, Sweden, and he's come to share some information with us. Hello, Dane, and thank you for taking the time to speak to us.
Thank you very much, Conrad. It's a pleasure to be here.
Excellent. Dane, can you give us a little further information with regard to technology of how we measure, instead of us having to go and buy expensive measurement devices, etc. Is there another way that you can measure far UVC that's relatively inexpensive and that you don't need to be knowledgeable about how these devices work?
Indeed. Let me say just a few words about Intelligo Technologies, because Intelligo Technologies was founded in 2011, so we are not a product of the pandemic. We're a company that started 11 years ago with the aim of providing an easy-to-use, efficient, hygienic, and very intuitive tool that, like you said, didn't require any heavy investments and was easy to use and easy to understand. I will just hold a few examples of our dosimeters. They are just thin like this, a few microns. And these are examples of dosimeters that we developed for the conventional UVC 254 nanometers for these situations, and when it was about, for example, disinfection in hospitals and so on. So before the pandemic, we had the aim of handling drug-resistant bacteria and so on. That is a still and will be in the future an even bigger problem, as we have seen as of today.
Absolutely. We also believe that superbuggers and AMRs, I think, are going to be our next big challenge.
Yeah.
Dane, can you explain to us? I see you have those dosimeter cards for 254 nanometer. How do those also measure 222, or do you have a different product for 222 that you've developed?
If I hold it like this is the newest product. We have a wide portfolio of products, everything from 254 to LED, and now also for 222. So this is the 222 dot, as we call it. And if I do like this, you can all see it's very easy to peel off. It's easy to place anywhere. It can be placed on a wall, on a door, on a bed, or whatever that is will be exposed. You use that dot together with a reference chart. It looks like this. And we have the steps of 20, 50, 100, and 150 millijoule per centimeter square in order to cover different situations.
Wow, that's an amazing technology. As far as I'm aware, it takes 3.2 millijoules to kill COVID. So your device starts from 20 millijoules, correct?
Yes. First threshold is 20. So when these dosimeter has been exposed to the energy level of 20 millijoules per centimeter square, it will change color for the first time. And we are talking about accumulated dosage. And when you continue to irradiate, the dosimeter dot in this case will continue to accumulate the dosage. And once the next energy level has been achieved, it will change to another color, and so on and so on.
Okay, that's an incredible product that you've developed there. If any of our delegates are looking for the product, Intellego Technologies, there's Dane. You can find them on the internet. You can go and have a look at their website, and they'd be happy to obviously get some of those dots through to you. Well, Dane, thank you very much for taking the time to chat to us. We will chat to you in a couple of minutes as soon as we get to the questions and the last part of the seminar. So thank you very much for your time from all of us. It really is appreciated. Thank you. So a couple of questions coming through. Will WHO, CDC, and or ASHRAE apply? So quick question. Will WHO, CDC, or ASHRAE apply the far UV triple technology in their disinfection guideline? What are they considering this technology? That's from Nick Horn. Anybody can answer that? Will the WHO or CDC apply the far UVC technology in their disinfection guideline?
Well, can you hear me?
Yes, we can hear you.
Okay. Well, I think step one was that the ACGIH has changed their threshold level values quite significantly. Chip last you mentioned that, and that was as of January the 1st. So I think that had to be step one, and then it's up to the other agencies to respond to the changes that the ACGH have made.
Absolutely, I do. I also recently was on a webinar with the WHO where they were speaking specifically about far UVC, which for us as a far UVC community was very encouraging for us. So they definitely have noticed it, they've taken note of it, and they are looking at it. Next question is, what do you see, this is from Rob from Human Sunlight, what do you see as the main benefits of semiconductor generated 222 nanometer light over Excimer lamps in this market?
I'll take a stab at that, but I mean, I think Dr. Tarasenko, I think, really addressed that issue pretty nicely. It's possible to do this right now, but the efficiency of these semiconductor LED devices at generating radiation in the far UVC range is very low, and their lifetimes are also very short. So, on the other hand, there's a history in the LED industry of meeting a need when it's identified. So basically the material scientists, at least as I understand it, need to sort of figure out how to make those LEDs so that that radiation can be generated more efficiently. And again, history suggests that they'll figure out how to do this.
Excellent.
Yeah, I would just reiterate what Chip said, that you'll find in various papers graphs of both the efficiency and the lifetime of LEDs as a function of calendar year, and they change dramatically as a function of time. So absolutely you would expect the 222 to follow the same path.
Absolutely. All right, another quick question. Where does far UVC stand in terms of health authorities like FDA and Health Canada? I think if I can answer this, I think Dr. Brenner, you already did answer this with regard to, with the work that IUVA is doing in the background and all the research and studies, etc., etc. Some of it still has to be completed before the FDA, etc., will start recognizing this product. Is that correct?
I'm sorry, was that directed at me?
Anybody, really? Yeah.
We haven't, or at least I haven't been contacted by FDA about this. I mean, we certainly would like to have a conversation with FDA to get their perspectives on this. But I'm not aware, to be honest, of where FDA stands on this. I think we really need to establish the scientific understanding and then move from there. But I think we're in a good position to do that now.
Absolutely. If I can just, to the three speakers, somebody's on a stream. Can you just mute that stream? It's coming through on the feed. If you can do that, that'll be great. Another question: in terms of efficacy, what can be done to show or convince the customer that the product does indeed kill viruses, bacteria, other than a before and after swab test? Is there a test one could do in real time to show the customer?
Well, I might just jump in and point to a study which was a joint UK-US study done at Leeds University, and there is a preprint actually available on the internet right now. And so that was a full-sized room, and there were lamps that were either at ACGIH levels or the oldest ACGIH levels, and the microbes were pumped into the room to an equilibrium level, and the microbes would continue to be pumped into the room, and then the lights were turned on. And at the ACGIH level, the equivalent air changes per hour was 180. So that is actually enormous compared with what we were talking about before, levels of 3 and 9 and so on. It is dramatically bigger, and effectively that is the equivalent of stepping outside. That's the equivalent. It's making an indoor room safe for airborne transmission of being outside.
Absolutely. I see there's also a study done by, I think it's Leeds University, Catherine Oakes, with regard to, that's very interesting to see, with regard to air change per hour and UVC. That's quite a good white paper. That white paper can be found on the website, alightbulbmoment.org, and that is a really good read. One question here. Is it possible to do an instant test result before far UVC is applied and after? I think, Dr. Brenner, you pretty much have answered that. So I wouldn't say it's possible unless you had actual COVID or an actual virus or bacteria that you know is there. And I think it is possible, but it needs to be obviously done in a lab, in a controlled environment, and needs to be done with all the right regulations in place and protocols in place to make sure that the outcome is the actual outcome. I know there are many white papers that have been published on the efficacy of it killing COVID-19, H1N1, and various different viruses and bacteria. So I always say to our clients, either you believe the science or you don't, and that's really, that's your choice. Me personally, I prefer to believe the science, as I'm not a scientist like Dr. Brenner is, so it would be better.
As you point out, I mean, you can do before and after studies, and they're not the ideal. You can measure the level of pathogens in the air before you turn the lamps on, and then you turn the lamps on and measure it after. So that's not perfect because the conditions may have changed from before and after, but it will give you a pretty rough estimate that the lamps are working.
I have seen I did read a story with regard to far UVC and air sanitation of I can't remember exactly where it was, but what they did was they put in a CO2 monitor, they measured the amount of CO2, etc. in the air in VOx and VOC, etc. They did I think they had it on for about 3 days to get a base, and then after that they turned on the UVC lights, and they took a measurement after 3 days, and it did show that it was a dramatic decrease from that monitor itself. So if you wanted to do something like that, you could always go and get a CO2 monitor or whatever and put it in, and you can do it yourself. But at the end of the day, like I always say, the science proves it. Either you believe the science or you don't. There's no better way to prove it than to have it done properly. Last question. Can you please give us a few examples of where your company has presently installed these lights, as well as the applications? So I'm not going to give examples of our company. This is an industry event, but from what I know, I will just rattle off a few. Far UVC, I think it's Technologies. Correct me if I'm wrong. In the States, they're rolling out their product into the Air Force bases. It's gone into the Millennium Building. It's gone into some fast food places. It's gone into frail care facilities. We've got there's installations that have been done in Trinidad and Tobago, India, Australia, New Zealand. Here in South Africa, we've got 6 or 7 sites here in South Africa where we've installed the product, and about to do a big install into one of the big healthcare facilities here. And what was quite interesting when they approached us was they were more concerned, or rather they had a really big issue with regard to absenteeism in their hospital and the stress it's causing on their staff who are having to work overtime, and the cost it was costing them to get other people in. So they weren't really even looking at it from a COVID point of view. They were looking at it from keeping people healthy. And that's also what I think everybody needs to realize, is that it's not just about COVID. It's about, in South Africa, we've got a big problem with TB. It's about H1N1. It's about all viruses, all bacteria. That's what this product kills. It's not just about COVID. So in Japan, I know they're rolling it out all over the place in Japan, and they used it in the Winter Olympics. It was product in the change rooms, etc., etc. So the product is definitely getting traction and is definitely being rolled out around the world.
I might add a couple of other placements. Just a couple of weeks ago, it was installed in a music bar in the middle of Boston, and via our friend and colleague Ed Nardell, who's a singer. And if you want to see far UVC in action and hear Ed Nardell sing, that's the place to go.
And was that in indoors?
That was indoors in a music bar.
Okay. Yeah. Okay.
And
Wow.
one other application in Canada, in Nova Scotia, it is installed in a large-scale elderly person's home, and that's actually one of the really nice applications of Far UVC, I think, because we've known all through the COVID crisis that it really affects elderly people's nursing homes really, really badly. So to install it there is a really good application.
Dane, Dr. Brenner, Chip, once again, thank you very much for your time. We really, really appreciate it. And here's hoping that our technology starts getting rolled out in more places and saves more lives. Thank you very much for your time.
Pleasure.
Pleasure.
All right. On to the polls. So one of the polls that we asked, do you believe this product, in other words, Far UVC, is safe to use in occupied spaces? Wow, 93% yes, 7% maybe, and there's a no from everybody. So we certainly have achieved the objective in the seminar of converting people from being skeptics to believers. It's amazing. Secondly, do you believe this product is effective in destroying viruses and bacteria? Again, very positive, 95% yes, 3% maybe, and 2% no. Also very encouraging. The third poll question was, do you believe Far UVC is more effective than fan-driven air sanitation products? 77% yes, 23% maybe, and 0% is no. The last poll question, do you believe Far UVC is more effective in sanitizing air and surfaces compared to upper air UVC and UVC robots? 70% yes, 25% maybe, and 5% no. So I must say, from the polls, this is all very, very encouraging for us in the Far UVC industry. One of our biggest challenges is educating the public on this amazing technology and letting everybody know that Far UVC is now completely safe to use in occupied spaces, and it really is the only product that offers real-time air and surface sanitation of occupied spaces.